2.1a, trig ratios with acute angles. So let's recall Pythagorean's theorem. A squared plus b squared equals c squared. Okay, so let's go over the definition of hypotenuse. This is the longest side in a right angle triangle. Okay, it is opposite to the 90-degree angle. So what opposite means is that wherever that angle is, the opposite side, we can put an arrow through. If you can see, we can't put an arrow through this side here, the one labeled opposite, or this one here labeled adjacent. Okay, only the hypotenuse. And I'm going to go over the reason why this one is actually opposite in just a second. Okay, and just as a recall, the sum of the interior angles in a triangle are 180 degrees. So we're going to use trig ratios. These involve Sohcahtoa. Okay, so sine opposite hypotenuse, cos adjacent hypotenuse, tan opposite adjacent. Okay, so this is how we do this. Whenever we're dealing with right angle triangles, if we have any 2 out of 3 of an angle or 2 sides, okay, so there's 3 things here. There's an angle, a side, and a side. If we have 2 of these, we can solve for the entire triangle using Sohcahtoa. Okay, so what we want to do is we want to label whatever angle we either have or we're looking for. And relative to that angle, we have to label the opposite and adjacent sides. So yes, hypotenuse is opposite the right angle, but it's not the actual opposite side. So opposite to x, we can put an arrow through it. It's here. And then adjacent is on this side. So if we think about our English classes and we think about the word adjacent, we think, oh, next to, beside, right? So the adjacent and the opposite always meet at the 90 degrees, and the adjacent is beside the angle. Okay, and then hypotenuse never changes. It's always going to be the long side of the triangle. Okay, and please note, the opposite and adjacent sides all depend on the angle being used. So when we switch that angle, the opposite and adjacent switch. So you need to find the opposite and adjacent sides relative to the angle that you're talking about. Okay, so we have 3 primary trigonometric ratios. So we have sine theta equals opposite over hypotenuse. That's where we get SOH from. Cos theta equals adjacent over hypotenuse. That's where we get CAH from. And tan theta equals opposite over adjacent. That's where we get TOA from. And there's 2 parts of this formula. Okay, the 2 parts are the actual angle part and then the ratio. And when you think of ratio, think of a fraction. Okay, I'm going to go ahead and show you hands-on how to determine the primary trig ratios for a triangle. Okay, it's not labeled, so we're going to label the x in this corner. Okay, relative to this x, this side is opposite. Okay, 90 degrees, this is adjacent. And the longest side is the hypotenuse. Okay, we don't know the value of the hypotenuse, so what we're going to do is we are going to do Pythagorean's theorem. A squared plus b squared equals c squared. So let's plug in 5 squared plus 12 squared, right? These 2 side lengths equals c squared. Okay, so we get 25 plus 144 equals c squared. I think we get 169 equals c squared. And then in order to get the squared off of the c, we can square root it. So we get c equals 13. Okay, so this is 13 here, and that's measured in meters. So now, this question just wants us to state what's sine x, what is cos x, and what is tan x. It wants us to state the ratios. Remember, the ratio is on this side. So even if we scroll up to take a look, we have Sohcahtoa. Okay, so for sine x, we have to put opposite over hypotenuse. So that's 5 over 13. For cos, we have to put adjacent over hypotenuse, 12 over 13. And for tan, we have to put opposite over adjacent, so 5 over 12. Okay, and these are the three primary trig ratios, those three right there. Okay, example 2, evaluate the following to 4 decimal places. So this just really gets us into the habit of using our calculators. So if you put sine 72 in your calculator, you should get 0.95111. Okay, now let's put cos 55 in our calculators, 0.5736. Okay, and if you're getting the wrong answers, it may be because you don't have your calculator in degree mode. This is actually usually what I do in class to actually test the students to see if their calculator is in degree mode, because if they're not getting the same answer as me, I take a look at their calculators. Okay, sine 71.9455 and cos 21.9336. Okay, example 3, solve for the unknown angle. Okay, the angle solving is easier than the side length sometimes. Okay, so in this triangle, I want to label the right angle. Opposite the right angle is the hypotenuse. Okay, we're going to talk about the opposite and the adjacent being relative to x. So this is opposite, this is adjacent. So here's the thing. We have the opposite side, we have the hypotenuse. So out of sine, cos, and tan, which one deals with opposite and hypotenuse? Sine. So sine x equals 5 over 12. Okay, if you put 5 over 12 into your calculator, you're going to get really long decimal, 0.41666666. Okay, but we don't want sine x, we want to solve for sine. In order to get the sine off the x, we have to actually sine inverse both sides. Okay, so once we sine inverse both sides, we get 24.6, let's round to 25 degrees. And usually for angles, we round to the nearest degree. Okay, change color. So, B, let's do the same steps. Label the right angle, label the hypotenuse. Okay, and then as relative to angle x, the 4 is opposite and the 6 is the hypotenuse, or sorry, the adjacent. My mistake. So this time we're dealing with opposite and adjacent. Sine, cos, or tan. Tan has opposite and adjacent. So we're going to label tan x equals 4 over 6. So if we did 4 over 6 in our calculators, we would get 0.66666 continuing. So this is clearly not our angle. We have to get the tan off the x. So what we're going to do is we're going to tan inverse both sides. Okay, and that gives us x equals 33.69 round to 34. degrees. Okay, last one, exact same steps. Label the right angle, label the hypotenuse. Okay, now relative to x, this side here is the opposite, 90 degrees is the adjacent. So let's take a look. We have the adjacent and we have the hypotenuse. So we're dealing with cosine this time. So we're going to put adjacent, which is 20, over hypotenuse, which is 40. So we're doing cos x equals 1 over 2. Or we can put 0.5 if you want to do the decimal. Now, how do we get the cos off of the x? We cos inverse. So we cos inverse both sides. What we do to the one hand, like left-hand side, we do to the right-hand side. And if you put this into your calculator, you should get x equals 60. Okay, this time what we're going to do is we are going to solve for side lengths. So a little bit different. We're still going to use Sohcahtoa, but rearranging is going to be a little different. So we're going to solve for the unknown side length x. Same first steps. Label the right angle, label the hypotenuse. Now, they actually give us an angle in each of these. So relative to the angle 55, this side 15 is going to be opposite. This side is going to be adjacent. So here's the thing. We have the opposite. We want the adjacent. So we're still dealing with opposite and adjacent, which is tan. So instead of putting tan x, we're actually going to fill in the angle. So tan 55 equals 15 over x. Okay, we're going to cross multiply that x up. So we have x tan 55 equals 15. And if you don't like the tan 55 in there, we can go ahead and put this in your calculator. You get 1.428 and then x. Okay? Now, in order to get the 1.428 off of the x, we're going to divide both sides by 1.428. And we get 10.5. Okay, so x equals 10.5, and that's measured in centimeters. Okay, B, same first steps. Label the right angle, label the hypotenuse. Okay, now we're dealing with the 48. The x is going to be the opposite, and then we have the hypotenuse. So at a sine, cosine, tan, we're using opposite and hypotenuse, which is the sine. So sine, fill in the angle right away, sine 48 equals x over 38. Now, this one's a little easier because all we have to do is cross multiply this 38 up, and we can put this 38 sine 48 into our calculator. Okay, it's already isolated for us. So we get 28 let's go 2. And that's going to be measured in kilometers. Okay, last one. Same steps. Label the right angle, label the hypotenuse. Now, relative to the 25, this side is the opposite, and this side is the adjacent. So, I have the adjacent, I want the hypotenuse. We're going to deal with cos. So we're going to go cos 25 equals 20 over x. Okay, cross multiply this x up. If you want to put cos 25 in your calculator, you're going to get 0.9063. And now we can divide both sides by 0.9063. And we get x equals 22 millimeters.